I'm Nathan Walmsley, and this is where I've been growing algae for the last 18 months. What I'm doing now seeks to understand the relationship between nutrient limitation in algae cultures and lipid productivity in the cultures. The lipid productivity of the algae is important because the lipids that the algae produce can be used to make biofuels. So the more lipids the algae produce, the more economically viable algae biofuel becomes. And until it becomes cheaper to make, it won't be able to compete with conventional fuels. So any way that can increase the algae's lipid productivity is very useful for creating biofuels. Under nutrient limitation, algae have been known to accumulate higher lipid contents, but this also decreases the growth of the algae. So it seems there's some point at which you could limit the nutrients and the algae growth and the algae lipid content would be at an optimal position for productivity. So I'm studying algae lipid production under nutrient limitation to find out the best way in which to grow it. I've ran batch cultures initially, but now I'm running continuous cultures. You see here the cultures are kept at a constant volume and they're being diluted by nutrient medium taken from these flasks at some constant rate, and then at the same rate well mixed medium in this flask is taken out so that the culture remains at a constant volume and is being diluted at some rate. And if I increase the dilution rate, so if I put in more and take out more, then that actually decreases the limitation of whatever nutrient I'm using. So in these cultures, nitrogen is the limiting nutrient, and as you can see, they're very dense. So the dilution rate, once I start it, I'll start at a very low dilution rate, and that would mean a very high nitrogen limitation. And then I will increase the dilution rate, and then eventually at each dilution rate, the algae will reach some constant concentration where they're growing at the same rate the culture is being diluted, and that will represent a different degree of nitrogen limitation. So by changing the dilution rates and measuring the lipid contents of the samples, I'm measuring the lipid contents at different nitrogen limitation rates. And I can do the same kinds of tests with phosphorus, potassium, and sulfur and find out what the best conditions to grow the algae are using this type of experimentation. And this is what one of the batch cultures would look like. This one is actually expired because it was a nitrogen depleted culture, but this is how the setup would work for those. So once I've studied the lipid content under these various limitations, I can model that relationship once I have more data, and doing this will allow me to find the best conditions under which to grow the algae, and that will allow me to produce fuel more effectively. Thank you.